In this video, we're going to talk about Terraform. First, I'm going to explain to you what Terraform is and what it's used for. We will see what's the difference between Terraform and Ansible and when to use each. We will also look at the Terraform architecture and commands, as well as an example Terraform configuration file. After that, you will have a good overview and understanding of how Terraform actually works and how it does its job. So first of all, what is Terraform? Terraform allows you to automate and manage your infrastructure and your platform and the services that run on that infrastructure. It's open source and it uses declarative language, meaning you don't have to define every step of how this automation and management is done. You just specify what you want as the final result or the end result, and Terraform will figure out how to execute it. Now this versus imperative style, where you specify how to execute each step. As I said, Terraform is a tool for infrastructure provisioning. So what does it mean exactly? Let's say you just started a project where you create some application and you want to set up an infrastructure from scratch. Where this application will run? How does your infrastructure look like? Let's say you want to spin up several servers where you will deploy your 5 microservice applications. That makes up your application as Docker containers, and also you're going to deploy a database container. Now you decide to use AWS platform to build your whole infrastructure on. So the first step will be to go to AWS and prepare the setup so the applications can be deployed there. This means you create your private network space, you create an employee server EC2 server instance, you install Docker on each of these plus any other tools that you might need for your application. Then you set up your security on your servers like firewalls, you set up network, etc. Once this infrastructure is prepared, you can now deploy your Docker application or Docker containers on that prepped infrastructure. So as you see, these are two different tasks or two separate steps of creating the whole setup. One is provisioning the infrastructure, preparing everything so the application can be deployed. And the second one is actually deploying the applications on it. So you might even have two separate teams or two individuals who do these two separate tasks. So a possible scenario, the DevOps team member configures the infrastructure and the developer then deploys the application on the prepared infrastructure. So where does Terraform come into this whole thing? Terraform is used in the first part where you provision the infrastructure to prepare it for the application deployment. Creating the VPC, spinning up the servers, creating the security and the AWS users with its required permissions. Maybe install Docker specific version on servers. Obviously, all this needs to be done in a correct order because one task may be dependent on other. Now here I must mention something that a lot of people ask when it comes to Terraform, and that is, what's the difference between Ansible and Terraform? Because they seem to be doing the same thing, especially if you read the official definitions or official documentation. They sound like the same tools. So the question is pretty logical. What's the difference between them and which one should I use for my project? So let's say the similarities and the differences between these two things, our example setup. First of all, Terraform and Ansible both are infrastructure as a code, meaning they're both used to automate provisioning, configuring, and managing the infrastructure. However, Terraform is mainly infrastructure provisioning tool. Now that's where its main power lies. But it also has the possibilities to deploy applications on other tools on that infrastructure. Ansible, on the other hand, is mainly a configuration tool. So once the infrastructure is provisioned and it's there, Ansible can now be used to configure it and deploy the application, install the updated software on that infrastructure, etc. So as you see, there is an overlap of what each tool does, and this creates a confusion. Other difference to consider in terms of these overlaps are Ansible is more mature and Terraform is relatively new, and because of that is also changing dynamically. And Terraform is much more advanced in orchestration. So to summarize the difference, Terraform is a better tool for provisioning infrastructure and Ansible a better tool for configuring that infrastructure, deploying, installing applications and services on them. So it's a common practice where DevOps engineers use the combination of these tools to cover the whole setup end to end, using both for their own strengths instead of just using one tool. Now if you want to learn more about Ansible as well, I have one video that I made about where I explain exactly what Ansible is and how to use it, so you can check it out. And I'll also create another video where I'll compare the infrastructure is a code tool like Ansible, Chef, Terraform, CloudFormation, etc. in much more detail. And also explain why each is best in one area even though they can do other tasks as well. So if you want to see those videos and if you want to learn more, then you can subscribe to my channel. You can click the notification bell and stay tuned for upcoming videos as well. So now let's go back to our use case where we created the infrastructure using Terraform and on AWS provisioned successfully for your project, and you deployed the application on it. Now we decide that we want to add 5 more services to the existing infrastructure to deploy more microservices, because your development team has added more features and they need to be deployed. And you also want to add more security configuration or maybe remove some stuff that you configured at the beginning. So now we are in a phase of managing the existing infrastructure, adding some stuff, reconfiguring, removing some stuff, etc. And using Terraform, you can make such judgments to infrastructure pretty easily. And this task of managing the infrastructure is just as important, because once you have created the initial infrastructure for your project, you will be continually adjusting and changing it. And because of that, you also need to have some automation tool that will do most of the heavy lifting for you, so that you don't have to manually configure and do some stuff. So once you are set up with Terraform to create and change or maintain your infrastructure, another useful thing or common use case could be replicating that infrastructure. Let's say after you've tested this setup and everything works fine, you decide now you want to release your application in production environment. So you want to create a production environment that replicates this exact setup, and keep the first as the development environment, where you can test new features, new microservices and updates before you launch it into production. Again, you can use Terraform here to automate the process. So you can easily spin up an identical infrastructure and setup using the same Terraform code that you use for the first setup in the development environment. And you can do the same to speed up an identical staging server as well. So that makes these tasks also very easy. So how does Terraform do all this? How does their configuration actually connect to this infrastructure provider platforms and use all these technologies to provision stuff? So for example, how does Terraform connect to AWS to create a virtual space or EC2 instances, configure networking? In order to do the job, Terraform has 2 main components that makes its architecture. The first one is Terraform core, and the core uses 2 input sources in order to do its job. So we can take Terraform configuration that you as a user write, and where you define what you need to be created or provisioned. And the second one is that from state, where Terraform keeps the up-to-date state of how the current setup of infrastructure looks like. So what core then does is it takes this input and it figures out the plan, what needs to be done. So it compares the state, what is the current state, what is the configuration that you desired end result, as I mentioned at the beginning, and compares that, and when it sees there is a difference, so you want something else than what your current state is, it figures out what needs to be done to get to that desired state in the configuration file. So that needs to be created, what needs to be updated, deleted, in which order on that infrastructure setup. And the second component or the second part of architecture are providers for specific technologies. It could be a cloud provider like AWS, Azure, or other infrastructure as service platforms. So for the infrastructure level tasks, the Terraform, as I mentioned, is also a provider for more high level components like Kubernetes or other platform as a service tools. Even some software is a self-service tool. So it gives you possibility to create stuff on different levels, like create AWS infrastructure, then deploy or create Kubernetes on top of it, and then create service inside that or components inside that Kubernetes cluster. So it gives you all those possibilities, and it does that through providers. Terraform has over 100 providers for these different technologies, and each provider gives Terraform user access to its resources. So through AWS provider, for example, you have access to hundreds of AWS resources like its two EC2 instances, the AWS users, etc. With Kubernetes provider, you get access to services resources like services and deployments and namespaces, etc. So this is how it works. And this way, Terraform tries to help you provision and cover the complete application setup from infrastructure all the way to the application. And this is really convenient. But as I mentioned in the comparison between Terraform and Ansible, Terraform's strength is actually in the infrastructure provisioning. And for the other stuff, you can use Ansible or similar tools. So once the core creates an execution plan based on the inputs from the config file and state, it then uses providers for specific technologies to execute the plan, to connect to those platforms and to actually carry out this execution plan. So now you also have an idea of how Terraform configuration file looks like. This is an example where you see AWS provider is configured, and through the provider you now have two AWS resources like VPC you can create and with some attributes. The same way you have Kubernetes provider here configured, and through that now you can create a Kubernetes namespace resource where you pass some attributes, and the syntax is very intuitive. I would say basically define what you want. You want a resource of a certain technology or a certain provider. It created, and then you define its attributes, and that's what Terraform will create or do for you. Now, one thing I mentioned in the beginning and I want to go into detail is the declarative approach that Terraform configuration files are written in. And this is important to understand. So what does declarative mean exactly? When you create a Terraform file, instead of defining what steps to be executed to create a VPC or to spin up 5 EC2 instances or create a network configuration, you define the end state you desire. So you say, I want 5 servers with network configuration like this, and I want one AWS user that has these permissions to access all the servers. Terraform goes and does that for me. So instead of defining exactly what to do, which is an imperative approach, you define what the end result should be, a declarative approach. Now for the initial step, this may not make much difference. So when the configuration of imperative and declarative approach, it might actually look pretty similar. But consider when you are updating your infrastructure, like removing a server or adding another server or making other adjustments. With imperative approach, you would say in a configuration file, remove 2 servers, add a firewall configuration, add some permissions to the AWS user, etc. So you give instructions of what you do. With declarative approach, like in Terraform example, you would say, my new desired state is now 7 servers. This firewall configuration and user with this set of permissions do whatever needs to be done to get from current state to new desired state. So now you don't have to actually calculate and decide how many services. You say, I want 7 servers at the end. That's what I want. Or you don't need to calculate and figure out how many permissions or which permissions you should add to just say, I want this set of permissions to come out at the end. So with the declarative approach, if you just adjust the old configuration file and re-execute it, instead of adding the new set of instructions, now this is obviously very comfortable because your configuration file stays clean and small. But also, you always know what the current setup is just by looking at the configuration file, because that's always the end result. Whereas in the first approach, an imperative one, you have to somehow add this up and figure out the delta between all the changes applied by multiple instructions. So you have created the Terraform file, configuration file, that defines your desired infrastructure setup on AWS. Now how do you make Terraform take action? Terraform has commands you can execute to go through the different stages, which is pretty clear and straightforward. The first command is refresh. With this command, Terraform will query the infrastructure provider, in your case AWS, to get the up-to-date state. So Terraform will now know what is the current state of the infrastructure. The next command is plan. Remember, I said the code is responsible for taking the current state in your configuration file as input and decide based on that difference what needs to be done. That's the plan. So what Terraform needs to do in order to achieve that desired state that you define in the Terraform configuration file? If it's an initial setup, it figures out all the steps to create the desired setup. If it's an update, it compares the existing setup with the new desired state and figures out what changes and adjustments to be made in which order to create the new desired state. For example, add a new server, add a new permission, etc. Now this is just a plan. Now this is where the code kind of constructs the plan logically, or what needs to be done. The next command is the command where the actual execution happens, and that's the apply command. So we would apply, you can execute the plan. So plan command is like a preview of what's going to happen. If you execute apply, obviously Terraform in the background will do the refresh at up-to-date state, then create the plan and then apply it. Which means if you want to execute a configuration file, you can just execute the apply command and it will do all this. And another command is destroy, which obviously destroys the old setup, removing elements one by one in the right order and cleaning up all the resources that were created. Basically reverting everything that has been created. And this could be used if you, let's say, you create an environment for an important demo day and you didn't want to interfere with the existing environment. Once the demo is over, you can destroy the whole setup. Now destroy, like apply, will also check what's the current state and create a plan of what needs to be removed in which order. So I hope this gives you a good high-level overview of Terraform and how it works. If you want to learn more such stuff, subscribe to my channel and stay tuned for more videos like this. Thank you for watching and see you in the next video.